Hello everyone. I, Miss Aarti Bansode, welcome you on behalf of the SIS Nehru College of Arts, Science and Commerce and the Department of Information Technology for the Bridge course for the academic year 22-23. The topic that I'm going to teach is called as algorithms and flowcharts. Now, what exactly is this topic all about? To give you a premise of this topic, I will tell you that when it comes to IT students are always talking about programming. Their entire life revolves around programming. So, what exactly is this programming that we talk about? Is it something really difficult? Is it something that is very challenging? Yes, it is challenging, but it is not difficult. Now, when I say programming, you must have heard about a plethora of programming languages. So now the student gets confused like which programming language is the best? How do I migrate from one language to another? The programming languages, they keep on changing. Say, for example, you study something in your syllabus, in your curriculum, you'll go outside, you might work on the same programming language. 5 years down the line, you see that it has been upgraded to another language. So how does a developer cope up with this changing trends of programming language? Now see, when it comes to a programming language, it is divided into two parts. One is the logic behind it, and the second part is the syntax behind it. So if I learn the logic behind a programming language, how exactly do I write the program, then it becomes easier for me to migrate from one syntax to another. See, the logic remains the same, the syntax keep changing. Like for example, when you're in your first year, you'll be learning a programming language, say like C. So when you learn about C, you study the for loop, the decision loops, you study the while loop and all those loops. You study different types of variables. Once you go to SY, might be you will study C++, and then you'll study Java. So basically, you'll be learning a lot of languages. And you'll see the same program that you did in C is now done in C++. And again, it can be done in Java. And once you go to your TY, you will do it in .NET. So the point that I'm trying to make here is that it is not about which programming language you study. It is about the challenge actually about programming. In programming is basically developing the logic for a particular program. When I say logic, what do I mean by that? I simply mean that there's a problem that you have to solve, and how do I go about solving the problem? And that is what this bridge course is all about. Okay. Now, when we look at any programming task, it can be divided into two parts. The what I'm trying to say here is when we are actually doing programming, the programming can be divided in two phases. You do not really get directly to typing the code into a computer. The first thing that you got to do whenever you have a problem statement is understand the problem. Understand what is the logic behind the problem. Try to find solutions to the problem. And that is what is the first phase, problem solving phase. So this is a very, very crucial phase um, because this is all very, very logical. You have to put your mind to it. You have to think about the task at hand. So, like for example, whenever you're trying to, play a game. So when you're trying to play a game, your goal is to win the game. So, you're supposed to win the game. Now, say for example, it is a maze that and you are at the starting point of a maze and you're supposed to reach the destination. So, whenever you are solving such kind of riddles, the first thing that you do is you look at the map of the maze and then you think about how do I go about reaching to the door. So you start thinking in this direction that, okay, let me take a right and might be I'll move to the next lane, then take a left, so on and so forth. You look at obstacles and avoid them. So somewhere, you are using your intuition, you're using your logic to solve that riddle. Every riddle is basically some set of steps that you're doing to solve the riddle. So programming is also like a puzzle. So whenever we are doing programming, there are two parts of it. First is solving the problem, and that is where your logic, your intelligence comes into the picture. The second part is the implementation phase. Implementation phase is dependent on what programming language you're working on. So the problem solving phase remains the same. Like say for example, whenever you'll be doing programming in future as computer science IT students, as well as when you become professionals and you start working in big companies, you'll be getting some problem. Okay, so that particular problem can be developed or programmed in any programming language, but the logic will remain the same. Okay, like for example, जैसे आप मोबाइल फोन खरीदते हो, there are apps. So WhatsApp for example is an app. Now WhatsApp का जो basic working है, whatever is the basic working, it remains the same irrespective of which operating system it is on. So when WhatsApp was developed for Android, the problem solving phase में it was just about the working of WhatsApp, and implementation is basically using Android for developing that app. Now when we made the same app for Apple, so the problem remained the same, the solution remained the same, only the programming language changed. Now when we are making it for Apple, we have to think of the iOS. So when, as I said, as in how we progress in your graduation career, or rather further ahead in your career in IT, in the field of IT and development, what you're going to do is you'll be devising solutions to problems. That is the problem solving phase, and the implementation part will keep on changing. It will keep on changing with respect to the trends in programming language. Like once upon a time, C was the most prominent language, most popular language. Then people moved on from C to C++, then they moved on to Java, then you must have heard about .NET, and so many programming. There are a lot of languages, C hash, there's so many languages, JavaScript, Ajax, Angular JavaScript, so many. So my point being that the implementation phase is, of course, it is not very challenging. You just need to know the logic, and then when it comes to the implementation phase, you just need to know the specifics of any programming language. So whatever logic you're using in the problem solving phase, that can be reused in multiple programming languages. Anyways, now coming back to what is shown on your screen, let's talk about what is written on your screen. Now, a typical programming task can be divided into two phases: problem solving phase and implementation phase. So what is a problem solving phase? It is used to produce an ordered sequence of steps that describe solution of a problem. So whenever we are talking about some set of steps, okay, which will solve a problem, that set of steps is called as an algorithm. So like as I said, there's somebody is ringing your doorbell. So what you gotta do, you gotta get up from your place where you're sitting, then walk towards the door. Okay, you go to the bedroom door, from the bedroom door you go to the hall, and then you open the latch, and then you let somebody in. So these are the steps that you perform. So that can also be called as an algorithm. Okay, so exactly on the same lines, whenever we are doing programming, we look at different programming tasks and then different programming examples, and then you want to break it into smaller tasks, and then you're going to write an algorithm for that, and further you're going to implement it using some programming language. So please remember, for a good developer, if you want to be a very good developer, you should be very good at the problem solving phase. Programming languages come and go, but the logic will always remain the same. Okay, moving on, let's see. Now when it comes to steps in problem solving, the first step is to produce a general algorithm, which is also called as a pseudocode. Now pseudocode, as the name suggests, pseudo matlab kya hota hai? Something which is not true, something which is similar to the original. Code, जो होता है, code is the actual program that you write when you are programming in any programming language. That is the code that you type. Okay. Now in your graduation, you'll be studying a lot of programming languages like C, Java, C++, Python. Okay. So that is coding. Pseudocode मतलब क्या होता है? Simple English में you write down what is the program logic. जैसे for example, you're going for a trip. So you simply write, okay, let's take a train from here to here, then take a bus, so on and so forth. So that is the pseudocode. And once you're done with the pseudocode, you've planned your journey, then you start refining it. Matlab, you start talking about it in detail. That is the second step, that is devising an algorithm. So now that I have spoken about traveling from say one station to another, using a train. Now in the algorithm, I'll specifically say that let us take the 9:30 local to CST from say Nehru station. So that is an example of an algorithm where you're specifically talking about what is to be done. Okay, and that's what. So when you're talking about programming, some people write pseudocode. Pseudocode is a very basic way to solve any problem. Algorithm is very specific where you talk about okay, जैसे ये input लेना है या output दिखाना है user को. All of those things come under algorithm. So the definition of pseudocode is that it is an artificial and informal language that helps programmers develop algorithms. It is very similar to everyday English, as I said. Then we are going to study something called as a flowchart. Now, flowchart have a lot of importance in programming. Like whenever you are making documentations, flowchart, as the name suggests, it is about the steps. As I said, we are just taking some steps. So flowchart will show the entire sequence of steps that you're doing. Okay, like if I gave you, like some time back, I gave an example that somebody is ringing your door and you're going to open it. So what you start, as I said, some steps are very simple. You get up from your bed or where you're sitting, you get up from there, you walk towards the bedroom door. From there, you walk towards uh, the hall or the living room's door. Then you open the door, or you might check through the peephole. Now there you gotta make a decision. You look through the peephole, and now you're making a decision. Is the person known to you? Should I let them in? Yes or no? If you know that person, yes, open the door. No, close. Do not open the door of it. You can just inquire who it is. So what you're doing there is you wanted to solve a problem. Somebody is ringing the bell. You wanted to open the door. So for opening the door, you did some actions, which was in a sequence, and you also had to take a decision. And all of these things that you're doing are represented in a flowchart. A flowchart is a schematic representation of the operations that you perform. Okay. Now, you'll see that whenever you're working on projects in your graduation, you'll be making project reports. In the project report, you will be making a lot of flowcharts where you'll be talking about how does your data flow, what is the input to the system, what do you do with the data, do you take any decisions, what is the output of the decision if the condition is met, if the condition is not met. See, this might seem a bit too much for you, but just remember the example that I gave for the doorbell. As I said, a flowchart shows the logic of an algorithm. So when I was talking about algorithm, flowchart is just a graphical representation of your algorithm. Now, by the end of this session, you'll understand what I'm talking about, because I am going to go stepwise. I'm going to start with, like, first part is I am going to start with the definitions, and then for every problem, we are going to write the pseudocode, the algorithm, and the flowchart. So flowchart, as I said, it is just a graphical representation of the algorithm. Here we talk about individual steps and the connection between those steps. At times when you're programming, it happens that one step, of course, it happens that you go from step 1 to step 2, step 2 to step 3, and then might be for some reason you go from step number 4 to step number 2 back. You can do that. It happens a lot in programming. So all of that entire flow of the program is represented in a. Now when it comes to a flowchart, it has multiple symbols which are used to denote different set of actions in a flowchart. Now the first symbol that you encounter whenever you're working with a flowchart is the oval symbol. Now the oval symbol denotes the beginning or the end of the program. Like whenever you're making a flowchart, you always start with the start symbols. You start with a circle, उसके अंदर हम लोग start करते हैं. Next is the parallelogram, which is used to denote an input operation. Jesse, for example, you're asking the user's name. So you're taking an input from the user. So that comes under parallelogram. The third one is rectangle. A rectangle denotes a process to be carried out. So it can be like, as I said, an addition, a subtraction, a division, like anything. Depending on what you're programming, you can just, or else, as I said, print something that all of those come under rectangle. Then we come to a diamond. A diamond is a decision statement. So here, whenever you need to make decisions, that is when we use a diamond symbol. So usually a decision has two outputs. One is true and next is false. So basically two outputs मतलब अगर true है तो next step क्या करना है, अगर false है तो next step क्या करना है. So usually the diamond has two arrows which go from it. Next is hybrid. This is basically denotes an output operation. Now see, depending on the book you refer, the symbol might change. And finally you have the flow line. It is just an arrow which talks about the direction of the logical flow of the program. As I said, we might go from step 1, 2, 3, 4 sequentially, or we might go from step number 4 back to step number 2. So अगर मुझे वो दिखाना है direction from step 4 to 2, I use a flow line. On, as I said, the flowchart symbols, there is, again, depending on, as I said, which book you are referring to. The first one is the terminal symbol, which indicates the beginning and end of an algorithm. So basically, start जो है हम लोग इसमें लिखेंगे. The process symbol जिसमें हम लोग instructions लिखेंगे. Then you have the IO symbol, which is a parallelogram, which we studied in the beginning. And now that we are working with technology में we have databases, we have files जो हम लोग access करते हैं. So this particular icon is used to, it is a symbol for a database. It's like a drum structure जिसमें save करते हैं data. And then you see the printer output symbol. See, flowcharts are used in mathematics as well as in computer science IT. So the symbols might vary a bit, but the logic remains the same. Flowchart is a graph used to depict or show a step-by-step solution using symbols which represent a task. The symbols which are used in a flowchart, they are all geometric shapes, as I just showed you some time back, and they are connected by flow lines. So instead of some people prefer pseudocoding where you write in English, these are the steps to be performed, whereas some people prefer drawing flow charts, just a graphical way of representing the entire program logic. Okay. This is an example of how flowchart looks like. So this is a flowchart sequence control structure where, as you can see, we are going from statement number 1 to statement number 2, statement number 2 to statement number 3, so on and so forth. And you can see that there are directed arrows.